10. So we have about 2 more lessons in this chapter. We have lesson 11 and lesson 12 before we're all the way finished. This lesson, hopefully you're going to see, goes right along with what we've been doing. We're just dividing again. The difference is that we're going to have some zeros up in our quotients today. So sometimes when you bring a number down, it's not going to be enough. So you have to put a 0 at the top and then bring down another number. And we did have a couple like that, remember, a few lessons ago?
I thought that's what you showed us yesterday, too.
Yesterday was our placeholder. So yesterday was if the first digit's not enough, where are we going to place our where are we going to place our first digit, like over the second one?
So this time, if you put this time you actually have to put a 0.
This time the 0 is going to matter as part of your answer, and you're going to need it there. Yesterday we used a 0 like as a placeholder at the beginning of the answer. Today we're actually going to be using zeros, and what that means is when you bring down a number and it's not enough, and you have to turn those 10s into 1s or something like that, and then you have to divide it again, so you're going to have to put a 0 up there. But we have done a couple of examples like this when we first did our dividing lessons. They threw in a couple like this, and you just had to see if you knew how to do it. So we haven't had an official lesson on it until today, but we have seen some like that. So this is another strategy that can be used to divide whole numbers. Really, though, we're just using the standard algorithm today, just like we have been in the last couple of lessons. We're not drawing any pictures. We're not using models or anything like that. We're not rounding or estimating except to check our answers.
Okay.
But in today's lesson, estimating will come in handy because sometimes if you forget that 0, you're going to get an answer that's really different than the answer that you should have. And if you've done an estimate and you've compared them, you should be able to catch those mistakes. So that will be another strategy. We're going to go back and use an old strategy too. All right, so here's your problem of the day for your whiteboard. Which number is less? So kind of like yesterday's question.
Okay.
Is it 2,000 more than 10,000 or 200 more than 10,200? So you have two numbers. One of them is here and the other one is here. Read the question. You're comparing two numbers. See if you can figure it out. 12,000, right? If you added 2,000 to 10,000, that would be 12,000. And the other number is 200 more than 10,200. So what number are we going to have there? Did I hear it somewhere over there? What did you get? 10,400.
Oh.
Because we're adding the hundreds. This is the hundreds place, so we're adding 200 more to 10,000. Because the number was 10,200 and it said to add 200 to that, which would make 10,400.
I accidentally added 200 to 10,000.
That's what they were trying to trick you with. So this number would be more. So the number that's less would be 10,400 because the other number is 12,000. So if we started comparing, right? Started comparing in the 10,000s place. The question was which number is less? Okay. Let's look in your notes. Let's have a look in your notes. Oops, not this one. One more. The question here for our investigate the math. I'll wait until you're ready to go. All you're doing is looking over into your notes. Just leave your whiteboard there. Even if it has writing on it, just leave it there. We'll go back to it in a little bit. In your notes, you need to write Chapter 3, Lesson 10, and it's called Quotients with Zeros. And our question up here is why would there ever be a 0 in the quotient? So we're going to figure out why there would ever be a 0 in the quotient. A quotient is an answer to a division problem.
Yeah.
Karnpreet.
There would be a 0 in the quotient because if the number is...
Hold on. These boys right here are being rude because they're talking when you're talking. So I want them to look at you and make sure that they're looking and listening while you're giving your answer. Go ahead, try it again.
If the number is too small, there has to be a 0 because the number is too small. It can't fit in the bigger number.
So if we think in our heads about the pictures that we were drawing before in a different lesson, if you're trying to, like let's say I separated some hundreds into my circles and I divided them all up, and then I went to divide the tens, but there wasn't enough tens to go around to all the circles, I would break the tens up into ones, and then I would have 0 tens. That would be a reason why you'd have 0 in your quotient. So when it's not enough and you have to break up the next, you have to add them to the next column and break them up, that's when you'd have a 0. So I told you that we wouldn't have to draw any pictures for this lesson. For the very first example, we're going to draw a picture only because I want you to be able to see what we're doing. And then we're going to do some other examples too. So our first one is 327 divided by 3. So here's how that would look. 3 is on the outside of the bar. 327 is on the inside. So we have 3 as our divisor, 327 as our dividend.
Oh, I see.
No, I want you to write this in your notes. So 3 goes into 3 one time. 1 times 3 is 3. Subtract. Bring down. Oops, that should be a 2. I'm sorry. Now, watch very carefully because here's the part that's probably going to be a little bit confusing if you're not sure about your long division. So, when I bring down the 2, hold on one second. When I bring down the 2 and I have to go to my next, when I start my steps over again, back into dividing again, I would divide 3 into 2 and I would say that it doesn't fit. So, here is where you would need a 0 in your quotient. So, the 0 would go up here. Then we're going to bring down the next number. So now when I divide, I'm going to divide 3 into 27. I'm going to show you one other way you can write this too. 3 goes into 27. How many times, Concrete? Oh, I thought you were going to give me an answer. Hold on. Let me finish this question or this problem, and then I will answer your question. How many times? 9 times. 9 times 3 is 27. I keep writing a 3 because I keep saying a 3. Okay, so your answer would be 109. Here is a different way that if you would like to write it this way, you can write it this way too. 3 goes in there once, bring down the 2, and then some people are saying, oh, that doesn't fit, so then they would write a 0 here also. Then they would bring down the next number. 3 goes into 27 9 times, that equals 27. Basically what I did over here is I skipped this little part of the step. If you would like to write that in, you can write that in. If you don't want to write that in, you don't have to. Basically, I brought down the 2 when it wasn't enough. Instead of making a minus 0, getting a 2 again, and then bringing it down, I just kind of skipped that little step there. So whatever way makes the most sense to you. Concrete, now you can ask your question.
Okay, what if there is not a number to bring down?
Then you would just put a 0 and your problem would be over. So basically, you mean if it was like this, 3 into 32, and you put that in once, bring down the 2, and then you say 3 is, it's not enough, then you put a 0 up here, and then 2 becomes your remainder. So here's where it's important to look and make sure that every number has a every part of your answer, every digit in your answer has a number below it. So if you have 3 numbers in your dividend, then you should have 3 numbers in your quotient, even if they're zeros. Because sometimes it's super easy to forget that 0. Sometimes when you're dividing and you go, oh, it's not enough, so you bring down the next number and you forget to put the 0 on the top, and when you do, you end up with only 19 as your answer, right? If I had forgotten to put the 0 there, I'd get 19. And then if you think about it, does it make sense that 3 would only go into 327 19 times? It doesn't sound like enough at all. So that's why your estimate would come in, or multiplying to check your answer. Now let me show you a picture. I told you I was going to show you just one picture. And I want you to write this in your notes. Here's your picture. Here's the picture. Yes.
That question is straight out of the first question.
Well, I'm glad you noticed.
But I have a question. Everybody write it in.
Okay, Aiden, what's your question?
I was going to say, what about, are we going to be adding in the remainders today or not?
There may not be many remainders today. If there are, you're not adding them in.
Okay.
Yeah.
So we're not going to, I thought you said that.
No, you're going to be, we're not interpreting today's lesson is not interpreting the remainders. That's tomorrow. And when we do that, we're going to be, it's word problems. That's how you interpret the remainder as a word problem. Then you will put it today. Yes. No, it'll be next week. So, look up at the screen. This should be in your notes. I've illustrated what 327 looks like. Maliki, yes, please draw this into your notes. Here's what 327 looks like. And I'm dividing it by 3. So I have 3 big circles down here. I'm trying to show you why you have 0 as in the tens place on this answer, because we know we got 109 as our answer, right? We should have that. We're going to have that on this too. So the first thing I do is I'm going to take these 3 hundreds and I'm going to put 1 in each of the circles. Remember we did this before. Now how many tens do I have? How many tens do I have, Nolan?
2.
2. Is that enough to distribute amongst 3 circles? No. So here's where my 0 tens comes in. Because now I'm going to take these 2 tens and I'm going to make them 1s. Aiden got it right. Now I have 27 1s. So if I distribute 27 1s amongst 3 circles, can I do that? Yes?
Oh, this is the check.
And how many 1s would go in each circle?
9.
9, because 9 goes into 23 goes into 27 9 times. So I'd have 9 in each circle. So when I look back, because this was like something that we've done this exact lesson before, where we drew the pictures. Well, that's only 6. Let me put 3 more on there.
You're already wrong.
So as I'm looking at my pictures and I say how many hundreds do I have? I have 1. How many tens do I have? 0, because there wasn't enough and I had to turn them into 1s. And then there's 9 1s in each circle. So you're doing the same thing when you're doing the standard algorithm, because basically when I bring a number down, I'm saying it's not enough. Pay attention. So when I went to distribute the tens, I said it's not enough, right? That's what I did when I was doing this way too. So when it's not enough, that's when you have a 0 as part of your quotient. So let's try this next example. You do not need to draw a picture on this one. 820 divided by 4. Try it by yourself in your notes. You don't have to draw a picture. Just do the standard algorithm. Don't need to draw only reason I showed you the picture was just to kind of try to illustrate what it was exactly that we were doing. Here's what I do. 4 goes into 8 twice. 2 times 4 is 8. Subtract. Bring down. Now 4 does not fit into 2. So because 4 doesn't fit into 2, I need to have a 0 up here. Then I could bring down the next digit. And 4 goes into 20 5 times. 5 times 4 is 20, so you get no remainder. So my answer is 205. And I've also double checked that I have 1 digit above every number that I'm dividing into. So part of your check at the end of this is to make sure that you have 1 digit above every other digit there.
That's what we're doing for our...
This is what we're doing for our math too.
Yeah, that's how our notes are. This symbol.
Hold on. We've talked about this before too. That if you think it's easy, I'm glad. That's good. That means that you've heard what I've been saying and you understand it. But what I don't want you to do is yell out, "This is so easy," because if there's someone who needs help, they're not going to feel like they can ask me a question if everybody's saying that's so easy and agreeing. Okay, so I need you to just keep it to yourself. If you get it, you get it, and I'll know that you get it. But you don't have to tell me. Let me answer the phone. Hang on. Hello, room 413. Here is our last example for your notes. Remember, you're keeping to yourself if you think it's easy and you understand. I'd like that. It's good that you do, but I want you to not share that with the entire class because it makes people feel like they can't ask something if they have a question. I just don't want you to say anything. I don't want you to say it's hard. I don't want you to say it's easy. I just want you to listen while I'm talking and make sure you get all the notes down. That way everybody can hear, right? Because if everybody's yelling things out, then not everybody's being able to hear. Here's our last example. This one kind of uses what we learned yesterday and what we learned today. Okay, so it kind of uses two things in one. So 7 does not fit into 5. So you can put an X, you can put a dash, you can put a 0, whatever you'd like to put there to hold the place. Then I'm going to divide 7 into 56. So that first part was what we did yesterday, where to place the first digit. Because 7 doesn't fit into 5, we couldn't put the first digit above the 5. So now how many times does 7 fit into 56? Karnpreet? 8 times. 7 times 8 is 56. Then I subtract, and I get 0. Bring down the next number. 7 goes into 2. Angelina, what do I do? 0 times. It does not fit, so I have to have a 0 up there. Then I can bring down the next digit, which is an 8. So what would I do next, Nolan?
Then you do 7 into 28 goes in 4 times. Then you do 7 times 4 is 28, and then minus 28 equals 0.
So now my final answer is 804.
Yes. Remainder 0.
You don't have to put the remainder of 0. Just put 804.
Wait. Remainder 0.
I'd like you to solve this question on your whiteboard, and you're going to hold it up and show me after we're all finished. So here's the question. Elena's school has collected, I'll wait till you grab your whiteboard, although it's right there in front of you. Really quick. Elena's school has collected $1,435 to use for student assemblies. If there will be 7 student assemblies, If they spend an equal amount on each one, how much will Elena's school spend on each assembly? So this is a division problem. Looks like you're going to be dividing 1,435 divided by 7. So see if you can figure that out on your whiteboard. I'll give you like 2 minutes. So here's what I saw on some boards. Check your answer and see if you did the same thing. 7 doesn't fit into 1. So I saw some people doing a dash like this, or an X, or a 0. 7 does not fit into 14, or sorry, it does fit into 14 twice. 2 times 7 is 14. Subtract, bring down. 7 goes into 3 0 times. It does not fit. So what I've done is taken those 10s and I've turned them into 1s. So now instead of 3 10s and 5 1s, I have 35 1s, right? So I'm going to bring down the 5. 7 goes into 35 5 times. 5 times 7 is 35. So that means they would spend a total of $205 per assembly. If you wanted to check your answers, here are 2 ways you can check your work. One way is to do an estimate. Instead of 7 into 1435, I might just do 7 into 1400. 7 goes into 14 twice. Add 2 zeros. Can we keep our whiteboards quiet back there? Just so everybody can hear what I'm saying. The other way is that you can multiply to check your answers. So 205 times 7. I take the quotient and I take the divisor and I multiply them together. So 5 times 7 is 35. 7 times 0 is 0. Plus 3 is 10. Sorry. That would be a 3. 7 times 0 is 0. Plus 3 is 3. And then I have 7 times 2 is 14.
21, yeah.
So you get 1,435. So there's 2 ways that you can check your answers.
Okay.
Okay?
I see.
You can either check your answer by estimating, or you can check your answers by multiplying. Either way. Look at your example page. Example number 1. This time, I'm the person speaking, so your eyes and ears should be towards me.
You can't turn our ears though.
You can turn your head so that you can hear me and then not listen to anybody else talking. Example number 1 says, Maya is saving to buy a television. The television costs $327. She plans to save money for 3 months. How much money does Maya need to save each month to buy the television? So we're going to let M represent the amount of money that she needs to save. So the question would be 327 divided by 3 equals M. Whatever M is going to be, that's going to be our quotient. So we're going to start dividing the hundreds first. 3 into 3 fits once. 1 times 3 is 3. Subtract and get 0. Excuse me. Bring down the next number, which is a 2. Can 3 fit into 2?
No.
Can't, right? So we're taking those 10s and we're going to turn them into some 1s.
27. Like we did in our notes.
Now all of these boxes here, remember that's where we're doing that. Make sure you have the 0 up here in your answer. Now we have 3 into 27, which would go 9 times. 9 times 3 is 27 with 0 remainder. If we estimated and made 327 into 300, it would be a pretty good estimate because 3 goes into 300 100 times. So our answer should be something close to 100, which ours is because it's 109. So Maya needs to save $109 each month. Our estimate was 100, which is really close to 109. Okay? Now, obviously, if you got 19 as your answer, like we said before, that would be a place where you'd want to stop because you said, oh, my estimate's 100, but I only got 19, so maybe I did something wrong, like maybe I forgot a 0. That could be something that you could look at. Okay, so that's what your estimate's going to be really good for, is just double checking. Example number 2 is 5,231 divided by 4. So we'll start by dividing the thousands. This one has thousands. So 4 goes into 5 once. 1 times 4 is 4. When we subtract, we get 1. We're going to bring down the next number, which is a 2. 4 goes into 12 3 times. 3 times 4 is 12. Bring down the 3. 4 goes into 3 how many times? How many?
4 goes into 3, 9.
None. 0, 0. So 0 goes up here. Bring down the 1. So now we're doing 4 into 31, which goes how many times?
Oh.
Anthony, how many times did you put on that one? How many times does 4 go into 31? That would only be 20. 7 times. And that's 28. And then when we subtract, we get 3 as our remainder. So our remainder is 3. Our answer is 1,307. Remainder 3. Now on this one, instead of using an estimate to check your answer, they're showing you that you could use multiplication. So you can do that by multiplying 1,307 times 4. And that would give you 5,228. And then you'd have to add the 3 in there to make it 5,231. So anytime you have a remainder and you're checking your answer using multiplication, you have to add the remainder in after you do the multiplying. Okay? All right, so we're up to guided practice.
This seems good, yeah, but I...
Well, you can show me how you've been doing it then in just a second, okay? That way, I don't want to confuse anybody else. So you can show me how you're doing it, and then we'll see what we need to do differently. All right, check the guided practice with someone in your group, and then you got your 20 minutes starting right now.